Let's take a look now at the architecture of the Pi system through a typical single site. And then later on we'll look at multiple sites that will go across the whole organization. So we'll start here over in the, the most far-flung geographically area with the data sources. We'll take a look at the control network, the DMZ. We'll explain what that is and then take a look at how this is served up in the client applications. So let me switch over now to our slides. And I'll start, as I said, by looking at these data sources. The data sources would be those things in the field that we're collecting data from. And if we look specifically at things like pumps, valves, etc., these temperature transmitters, pressure sensors, etc., flow meters, these are the things that are physically connected to the equipment that you're using. And in the case of things like SCADA systems, you would have connections to transformers to the different pieces of equipment out in the field for transmission and distribution of those things that you manage. Now, those data sources generally are connected to some kind of a control system, whether those be programmable logic controllers, or controllers, a SCADA system, or a distributed control system. And that's part of what we're calling here the manufacturing control network. That would be the highly secure area of your network in which you don't want anybody but authorized users. This is where you open and close valves. You can actually do things to your plant. So obviously you only want the most secure, trusted individuals who have access to that. Now compare that to this DMZ. DMZ stands for, well, it's an old military term, demilitarized zone. It's also sometimes known as the data management zone or demarcation zone, or simply just a perimeter network. The concept is it's an area in your network. It's usually a subnetwork, a logical area, or sometimes physically a different network, in which you're going to take those pieces of information that are generated back here in your highly secure network, and you're going to expose them in a very careful, measured way to the outside world, to the unsecure network, generally the internet. So you need to do that very well with good firewalls in between, so that nothing that happens out here, in the Wild West here, can actually get in and do anything on your manufacturing control network. And that's what the DMZ does. And that's generally where you're going to find the Pi system, the interface nodes, etc. Those are going to be it typically will be in your DMZ. Now, once we have that data on the Pi server, we can do analysis to it. This is what we do with our analytics tools. Things like our notifications, our advanced computing engine, calculations, notifications, statistical quality control, trends. Those are the types of things that people are going to be using to make some sense out of all that data that you're bringing in. So we have good analytics tools for that. And of course, the big finish is once you've got information that's useful, that's actionable, that will actually improve things in manufacturing, you want to show it to people. So again, typically through another firewall, you will find access to that data is done through the client applications, either our rich client or smart client applications like Pi Process Book and Pi Data Link and others. Also through thin clients like the RT Web Parts or other web-based applications. Like for example the applications that support the SAP portal technology. RT Web Parts, by the way, you may know as Pi Web Parts. And typically the location of this is going to be out on the corporate LAN or actually completely out on the internet. Using good credentials, piggybacking on Windows security, you can expose this to people in a way that's secure, even if they're sitting at home or in an airport. And so far we've been discussing just a single Pi system on a single site. But remember, this is meant to be an enterprise application. And what we typically find is you'll have many, many different sites involved in this. So this might be one Pi site. This over here is another Pi site. We've got a third Pi site down here. And all of these things can be wrapped up to be looked at in general across the entire organization using those same Pi technologies that get the data, from on a local level here, from the data sources to the users. We can use that same technology to collect that data into these enterprise servers and then serve that data out to end users. Like you see here, the end users can, through the technologies of our SDK and our API and our OLEDB application, we can also share that data to other devices and other systems that require real-time information. So, for example, if you do have a business system that requires this real-time data, odds are we've got a mechanism either through our OLEDB provider or some other interfacing. We have some mechanism for you to get the data in all the way from the shop room floor into that business system. And then, of course, we support all the other technologies for getting this data out to people through portal servers, mobile clients, wireless connections, etc. I don't think this picture would be complete if we didn't mention that in addition to getting all the data from manufacturing and bringing it to the users who need it, well, these systems themselves, these enterprise systems, they do consume a lot of resources, and we do have tools for monitoring those resources. So it's not unusual at all to see a customer who's using Pi for monitoring his manufacturing process also use Pi in his data center so that he can monitor things like heat or energy, etc., so he can better run his data center. In addition, he can reach out and grab Windows performance counters, SNMP data, network traffic, routing information, etc., from his network, bring that into Pi with a unique set of analysis tools that can get down to practically to the sub-second level, no averaging necessary here, and do troubleshooting for his internal resources, his server farms, his networks, etc.